Hello, let's solve pips. We've got 1 by Ian, 2 by Rodolfo. Today we'll start with the easy puzzle. Let's place some dominoes. Okay, so we need a 6 connecting to something that doesn't break a 3, which could be 6, 3, then a 0, or it could be 6, 2, and then a 1. Both of those works. We don't have, no. We also need, we either need 2 of something up there, or we need 6 connecting to it in a way that won't break it, which couldn't be this 5. It couldn't be this 2, actually, because if it were this 2, we would then have to put our double 2 here, and we wouldn't be able to finish the other 2 regions, so that doesn't work. But it could be the 6, 3. Actually, could it be? I don't think it could be. It couldn't be the 6, 3, because then we'd need this 3, 0, and we don't have another 0, so that's actually not possible. So if the 6 points up, or maybe it couldn't be anything. Yeah, it couldn't be anything if the 6 points up, so it doesn't. So we do need 2 of something up there, which means 6 goes left into, it still needs to be something that we have 2 of. So it still can't be 5. So it's 2 or 3, which means also 2 or 3 goes that way. It probably should be much easier than I'm making it, shouldn't it? Yeah, this works, though. No, it doesn't. No, it doesn't. Okay. Sorry. So that's not 6, 2. So it is 6, 3, I guess. And then our 3 goes there. It's the only way to do that, which means we need a 5 connected to a 6. Yeah, this works. So now we have our 6 connected to the 3 region. We finish it with a 1, and we put our 2's up there. Oh, come on. There we go. Okay, this probably shouldn't have taken me so long. Let's move on to medium. Right, okay. We've got, I don't know, almost a sort of swan or something here. So we need greater than 4 connecting to 6, or something that doesn't break 6. So we need a 5 or 6. So it's either, actually, I don't think it can be this one, because then we'd need another 5, which we don't have. So it is actually this 6. So now we have a 3 pointing down into the 6. And it can't be this 3, 0, because we don't have a 6 domino left. It could be the 3, 2, in which case the 4 would point. No, it couldn't be. If it were this 3, 2, then the 4 would point down, and we'd need another 6 in that 6 region. Yeah, we have all of these 6 regions, and those are the things that are causing problems. So I think that means it's the double 3, which means we have 3 pointing down, which means it's this 3, 2, so it can't be the 3, 0 for the same reason. We now need 4, which must point down, because if it pointed across, we'd once again break that 6 region in the same way. And now we can finish our 6, make the less than 3 all 0s, and there we have it. Okay, so that was easy. I found that easier than the easy, but let's move on to the hard. Okay, we've got a sort of equal sign here, which makes sense because all of our indicators are equivalence indicators. Okay, so we need 5 of something. What might that be? Could be 3s. Could be 5s. 3s or 5s maybe only. I think only 3s or 5s fit in the 5 region. So what do we have at least 4 of? Because we have 3 examples of that. 0s, 3s, 5s. Wait, I must have missed one. 0s, 3s, 5s. Okay. Sorry, I'm just missing dominoes here. What? This is horrible. What do we have at least 4 of? There need 0s, 1s. No, not 1s. We only have 3 1s. 0s, not 2s. 3s, not 4s. 5s, not 6s. What am I missing here? We don't have 8 of something, do we? There's no way. Sorry, I'm just missing something. I'm just not. There's something I'm not counting. This is ridiculous. So it's 0s, 3s, 5s. I'm losing my mind here. This is unbelievable. Sorry, we need 4 of something here, 4 of something here, 5 of something here. So we need at least 3 digits that each have 4 examples of them. What on earth am I not counting? Zeros? Oh, wait, no. Sorry, we only need 3 examples. Zeros, threes. Yeah, it is zero. Sorry, it's 0, 3s, and 5. What was I thinking? I thought we needed 4 examples of that, but of course we don't. So it's 0s, 3s, and 5s. Sorry, I'm really not acquitting myself well here. And of the things that have 5, it's 3s and 5s. So the zeros go either in this box over here or this straight line over here, this straight and narrow line over there. If they went in the box, this would need to go here, which would mean we would need 1s and 3s pointing out there. Now the 1 couldn't point there, it would have to point here, which would mean 3s would have to point here. And then double 1 would mean that would need to be there, which would mean double 3 needs to be there. Is any of that useful? We could still put 3s in the 2-sized equivalence region, or they would have to both go into voids, which feels tricky, actually, but maybe not tricky enough. Yeah, probably not tricky enough. So we have 3 6s, and they can't all go into the voids. So one of them does need to go into an equivalence region, either size 2 or size 3. They can't all go in the void, because then if they did, we'd have 6s pointing somewhere else. So like they could go into that void, but then we would need another 6 here, which is possible, actually. But I'm just kind of doing things at random at this point then, if that's what I'm doing. Maybe it's a question of figuring out what does need to go in the voids. How do we allocate these such that we understand what we have extras of? This would be a great example of where I would just love if I could move these, rearrange these dominoes down in my little pen myself. I find it really hard to keep this stuff in my head. So we've got 4 zeros, and those go into one of the 4 regions. We know that. We've got 3 1s, which either go into this 3 region or this 2 region, and 1. Okay, what do we not have enough of? Maybe that's a better way to look at it. We only have 2 4s. So the 4s either go in this region or they go into the voids. So is it easy or difficult to allow them to go into that region? Now, one of our 4s is connected to a 5, and the 5 could be the thing that we have 5 of. What about the 3s? We also have 5 3s. Interesting. That does make it seem like maybe it goes up here, but it doesn't necessarily need to. What do we have double dominoes of? 6, 5, 1, 2, and 0. That's plenty. Now, how does this work? What's the logical way of dealing with this? I'm not sure. What about 2s? Do we only have 2 of those? Is it difficult to put them here then? Actually, maybe that's the only place they can go. Maybe it is. Because where else could they go? If they go into, do we just have to, yeah, okay, this seems right. Should have noticed this a while ago. Because if they go into any of the void regions, they imply more 2s in whichever equivalence region they enter. And that's not possible. So these do go there. These do go there, which means we need a double right above it, which means over here, they on the right side of this kind of backwards sort of inverted L thing, they poke out. Both of them poke out. So, okay, that's something. So that was helpful. And we also have 2 4s, right? But since we don't have another 2-cell equivalence region, that means the 4s definitely go in the void, which means we need one more thing that goes in the void. So that'll be presumably something that we have 5 of. Yeah, it'll be something that we have 5 of. It'll be 3s or 5s. So A3 or A5 goes into the void. Also 2 4s do. So 2 4s and a 3 or a 5. That, I think, makes sense. Because anything that we have 5 of, only one of them can be fully consumed by the 5-cell region. The other one will have to go in a 4-cell region. So 3 and a 5 and 2 4s. And it's interesting that our 4s have 3 and 5 attached. That is kind of interesting. That makes sense, I suppose, actually, now that I think about it, because, one of them will go here. Will connect to that thing. So the other one, sorry, what I meant to say was our excess 3 or 5 will need to connect to something. So the 3-5 domino, no, I guess it could go into, we could do this. We could waste one of our 5s, which then goes in a 4 region, and we could put, the other 3s up here, but I don't know if that's correct. Okay, so that's the situation with 3s, 5s. One of them goes in a 4 plus a void. The other goes in a 5. So what about our 6s? Everything else needs to be fully used. So our 6s go in a 3-sized region. 0s go in a 4-sized region. What's our other 3-sized region? 1s. 1s are the other 3-sized region. And again, we can't waste any. So none of them can go into the, none of our 1s can point into a void. Our 6s maybe could, in theory. We could do, say, 6-5 over here, just for instance. Actually, we couldn't. No, we could. We could, in theory, do that. Because then we could do something like, double 3 here, and then we don't have a 3-6, actually, so that wouldn't work. But double 5, I guess? And then, no, actually, that doesn't work either. Oh, that's interesting. Because we would start needing something that connects to a 6. Oh, yeah, maybe this doesn't ever work. We can never point. Yeah, there's no 6 that could point out there in any way that would work, actually. Does that mean this can't be a 6 region? Is that what that means? I'm not sure. Not necessarily, because, yeah, this could do that. Then we would need double something above it. Then this would have to be, well, it couldn't be this. It couldn't be this. It would have to, if there were 6s in there, this would have to point this way. Then we would need this to go here. Then we would need, this would have to be 5-3 up here. I'm just trying to get a handle on what the sort of different ways that these things could work will be. Then this would have to be 3-4, I think, because our 4s go into to those areas. Then we would need our other 3 to go into the void. So this would have to be over here. No, this doesn't work. This doesn't work. What was the point at which this went wrong? We need to put our zeros into a 4-cell region, don't we? Yes, because one of 3 or 5 goes in the 5. Yeah, right. That's why this didn't work. Sorry. I was wondering what was going wrong with this. Sorry, that was all predicated on this, I wasn't suggesting that was the correct answer. I was just trying to play around with the grid and understand how it works. But it is actually difficult to put 6s in this. Could it go this way? I don't think it, well, I guess it could if this went here. Then this would, no, this doesn't work. So that's not 6s down there. So I think that does mean, actually, so it wasn't really my intention to just keep banging away at that, but it's what happened. I think that means the 6s are in this region up here, which I think means this would need to go here. Is there a different way to do that? If we put this here, yeah, no, this can't work. We always need these bridging. So I think that means this needs to bridge here, and that goes there. And then we would need double 5 up here. I hope that what I'm saying is correct. Then we have to use both of our other 5s, which means it doesn't really matter which way they go. One of them could go here. One of them could go here. So we need 3s in this, well, in one of these four-sized regions, and 0 in the other one. So 0 and 3 are going to be connected to each other. And then 1s go, oh, maybe it's the way around because the 1 needs to bridge over there. So I think that means this is the 0 over there. And this goes here. And then we have 0, 3 going here. Yeah, okay. So this took me longer than it should have, but I finally understand it. I finally understand how it all works. And there we go. Okay, so yeah, it took a little longer than it should have, but there we have it. That was the hard puzzle. All right, those are the pips. Back tomorrow. Bye for now.